In this video, we'll be looking at how to construct a tangent to an ellipse. So as we start this construction, I'll take it that you already have an ellipse constructed. If you don't know how to construct an ellipse, I'll put a link in the description so that you know how to construct an ellipse. So before you start your construction, you need to name your points on an ellipse. But as you get better at the process, there's no need to name the points. But if you're just getting started, it's better you name the points so that it's easy for you to follow up on the construction. So you can name the points on the ellipse as follows. The center of the ellipse, name it O. Then where the ellipse passes the major axis, or the furthest point from the center of the ellipse to the circumference of the ellipse, name that as point B. It doesn't matter whether you put it on the right or on the left, it's still the same thing. Then you name the minor axis, where the ellipse passes the minor axis, as point A. It doesn't matter if you put it here or on the other side. Again, this method also applies if the ellipse is oriented in the vertical way. So once you name the points, we'll go to the next step. So the next step is to locate points F1 and F2. So these are the focal points of an ellipse. So to do that, you need to open to a radius that is equal to half of the major axis. So the way you do that is you open your compass, you stand at point O, then you open to point B. The radius you open there will be half of the major axis. With that radius, stand at point A. With point A, cut the center line that is along the major axis. So once you cut the center line on the left and on the right, those 2 points will be the points F1 and point F2. Keep in mind this radius is half of the major axis. The next point is you join point F1 to the point where you want to make the tangent. So this point P, it can be at any point along the circumference of the ellipse. You join point F1 to point P and point F2 using construction lines. Once you do that, you bisect the angle made by F1, P, F2. So this line to point P and the line from point P to point F2, it will make an angle. So what you do is you bisect that angle. The way you do that is you get your compass, open to any convenient radius, stand at point P, strike an arc to cut the line going to F1 and cut the line going to F2. Then you get your compass with the same radius, stand at this point here where you've cut on the left and strike an arc, this arc here. Then you stand at this point where you've cut F2, you strike an arc there. Where those two arcs meet, you draw a line from this point here, passing through point P, then you extend it outside the ellipse. Next is just to put a tangent. So what you do is you are going to put a line that will be perpendicular to this line, the bisector to the angle. So the way you do that is you get your compass, open to any convenient radius, stand at point P, open to any convenient radius, strike an arc to cut this line, and strike an arc to cut this line. Once you do that, you extend the radius of your compass. After extending the radius of your compass, you stand at this point where we just cut, strike an arc, stand at this point where we just cut, strike an arc. Where those two arcs meet, you draw a line passing through point P, passing through the point you've just cut. If you extend the line this side and the other side, you have a tangent. So when you're constructing a tangent, there are a few things you need to know. We already know that this line here is the tangent. Then this line here, that is at right angles to the tangent. This one here is called the normal. So this here is the tangent. Then this line here is what you call the normal. In any construction, the tangent is supposed to be at right angles to the normal. So this angle here is supposed to be 90 degrees. So that's a simple construction on how to make a tangent to an ellipse.